All right, in this video, we're going to go through on the Chem control box the software and kind of like the reference software that you're given, how to use it, how do you program it to get you started. So before we begin, I'm going to bring up the website for Mbed. So the microcontroller that is used to drive everything on the Chem control box is one of these Mbed platforms. So all an Mbed is a microcontroller on a little board that has a nice bootloader and a nice online system for libraries and whatnot. So we are using the Mbed LPC 1768. This was actually the first Mbed platform made. Think of it as somewhat like if you've heard of the Arduino platform. It's just a microcontroller with a convenient, easy way to program it. The difference being it's very powerful. It's much more powerful than your Arduino system, and it kind of gives you a lot more to play with. Since its introduction, there's been a lot of other platforms, but we're using the LPC 1768. So when you look at the Chem control box, you'll see this device plugged in. And it just exposes a bunch of the I/O we use out to like header pins, so it's socketed for us on the board. And everything kind of happens programming-wise over this USB port. The cool part about Mbed, the reason it's easy to program, is that anytime you just plug it in, it shows up as a mass storage class device. And what that means is that when you plug it in, it looks like a little tiny thumb drive. So the way you program the unit is to simply drag and drop your compiled program. So that makes for kind of like the user it really easy to use. So the first thing you should do before we do anything, and you can pause it here, is with all the Chem control boxes, there is a handful of Mbeds. Is plug it in, and you want to register register, and you can even plug an Mbed in without being plugged in the Chem box, just to play around with it. But you have to register to get to the compiler. So let's take a quick look at what happens when we plug it in. So for me, it came up as removable disk K, and there were two kind of files on it. One was a file that as I was testing the firmware, I was dragging and dropping on Chem control. It was kind of like number 10. And the file that it generates the compiler is just a .binary, a .bin file. Now, anytime you plug in a new Mbed in, you get this mbed.htm. And what that is just, it takes you to a special sign-up page that kind of like has a code in the Mbed, and you can sign up to get your own login. So I've already done this. You can go ahead and do it. Now, what I'm going to do is I'm going to click on, when I go to the platforms, one thing I'm going to show you, and the thing that made Mbed kind of popular, is that a lot of the programming of the hardware was abstracted with nice C++ libraries. So on the handbook section, they have all these examples of how you just talk to basic stuff on the Mbed. Now, for the Chem box, I've even kind of taken a level further. There's lots of custom hardware where I used a lot of these functions, but all you have to do is make simple function calls. And that's what made the Mbed popular. So, for example, a digital out object, you declare it, and it's really easy to use. So in their Blinky example, whenever you create a new program, it kind of shows you. So that was the nice thing about Mbed. So I'm going to click on compiler. Let me type in my username and ID. And so this compiler works right in a web browser, so you don't have to install anything. Now, for me, it kind of brings up this interface. Now, I have a bunch of programs that I've done, over the years. So with the Mbed as I'm playing with it. So I'm just going to show you first. We're going to take a look at how you create a new program, but then we're going to see how we import the ChemBox program that I've published. So whenever you make a program, you can publish it to their online system so that others can kind of pull it down and use it. So it's kind of like an open source kind of thing. So what's kind of neat, and you can play with this, but when you ever create a new program, by default, it'll always give you like a template you can use. So I'm just going to call this test. And what it does is I have a test program, and it shows you how to blink an LED, on the embed. So if you have a raw embed, I would recommend you compile this. And on the website, they kind of show you the process. So I'm going to go through the process not with this, but with the Chem control box. So what I'm going to do is I've already published this program. So I'm going to go to embed.org. And I'm just going to type in ChemBox. And you'll see Eli Hughes, that's me. And this is kind of like the page that it generates for example projects. So as I make, say, fixes, or you make fixes, you can push them to here. And I'll have more data on this web page as it goes along. But what you can do is we can just go import this program. So it's going to open up the compiler. Let me close this other one. And it says, what does it want to import? And I'm just going to call this Chem Control Test. I actually have a different one open. So I'm going to call this Chem Control Test. You can call it whatever you want. So it's importing. And notice it shows up right here. Here is the one I've been doing development on. Here's like another copy of it. Now don't worry, as you're editing, if you have a test one, it doesn't make a change on the website. You actually have to go through a process to get it to changes on the website, and we can work through that another time. So what I'm going to do now is step you through like the source code and how you upload it. So the first thing we're going to do is I'm going to click on main.cpp. And what this is a basic template that's going to be there for like all the demonstrations I'm going to show you. So there's enough here where someone who has a little bit of programming skill could kind of look at it and figure it out. Now, embed is all C and C++. The good news is the embed libraries and libraries I've given you, they're pretty foolproof. You don't have to know a lot about low-level C to program it. And once you look at a program, you'll kind of get an idea how it works. So, some things I want to point out. So all of the low-level drivers that I wrote are in this drivers folder. So if you're ever curious about seeing the source code, it's all here. It's in this ChemBox common. And you can scroll down, and this has all the low-level code that makes all the hardware work. Now, the good news is you don't ever have to worry about how all this stuff works. The other file in the driver is called, it's the .h file, what's called a header file in C++, that has the function declarations, meaning it has all the names of all the functions in the actual driver C++ file. And if you read through this, you'll see all the function names I've given you that you can just call to make things work. And so, for example, here's a function called init ChemBox, and it says, okay, this initializes the hardware, must be called before any ChemBox program. So you can look down through here. So here's enable heater channel, disable heater channel, enable solenoid valve, and it's pretty self-explanatory as you read down through here. Now we're going to come back and look at this in a minute in more detail. I want to show you basically how you compile the software out of the box and some other high-level features that I have in the program. So I'm going to go back to main. Now the only other thing that besides the C file that's a dependency, a library, there's another library in the embed ecosystem called mod serial, and it's a serial port driver that has a nice queue on it. And I really like using it as a serial port driver. They have their own stock one, but this one has some other functions. So if you were to create a project from scratch, you basically need these two files and mod serial. But the easy way to start a new project is just to import the stock, example, and edit that before you get going. So before I actually look at any of this source code, we're going to look at how we just build this thing. So I'm using Chrome. the web browser. So you just click compile. And it gives me a little warning here. Don't worry about that. What that is in some of my comments, I put these big ASCII art graphics. It has a warning, but don't worry about that. That's not an error. That's just it doesn't like some of the white space characters in there. But the big deal is it says success. Now, different web browsers are different. When you compile an embed program, it generates a .binary file and downloads it to your computer. So I think if you use Firefox or Internet Explorer, it'll bring up a little download window. Well, Chrome, it puts it in its download area. So what I'm going to do is go to my downloads, and it shows me Chem Control Test. So I'm going to go Show in Folder. Now, you'll notice here all these other versions. So let me do something for a minute. So I just wanted to clear out all the other stuff in there. So I have this binary file. It's not very big. This is the whole program. So let me show you how you program it. So what I'm going to do is kind of go like that. Now I'm going to bring in the embed drive. I can delete this old one, but it doesn't matter. All you do is you drag and drop it over to the embed drive. And then it downloads the program. Now, I have the Chem box. You can't see it, but I'm going to hit reset. And I hear the Chem box beep. You'll hear it when you have it in front of you. And the new program's loaded. Now, let's say I want to compile it again. I'll just hit compile. Now, I should come over to my downloads folder. Notice it has like a new program. It puts like a little 1. That's what Chrome does. Now I can just drag and drop this over here. Now you can have more than one bin file on the embed drive. And what it does, it always programs it with whatever the latest one, whatever has the latest date on it. So you can have multiple on there and it won't hurt anything other than fill up the drive, the embed drive. So it's programmed. All right. So that's the programming procedure of how it works. Now, before we look at the low-level code, I wanted to show you one other feature of the embed that will help you as you kind of play with ChemBox applications. So let me minimize that and minimize that. One other feature that the embed has is that USB port that's on the front. Actually, let me go to the main site. I'm going to go handbook. Is that not only can the embed look like a thumb drive, but it can also look like what's called a virtual serial port, where it'll look like a serial port inside of the Windows Explorer. So you can talk to it from a PC. But what you got to do to get it to work is on the embed handbook serial page, there's a driver that you've got installed called, I'll click on Serial PC, and it has a link, to the driver. You've got to run this driver. Now, what I'll do is let me bring up my my device manager. Just to kind of show you that for mine, I already have it loaded. And you notice I get something called the embed serial port. After you load the driver, you get the embed serial port. Now, one thing in the example code, you don't have to use it, but it's a good way to debug, is that before you write any code where you embed a control algorithm, all of the I/O on the Chem box is kind of exposed through the serial port, so you can have a remote program, such as LabVIEW, and I provide an example, control it. So, in the Dropbox where I put all the documentation, there is a file, it's called Chem Control Box USB Interface Details, and I open that up in Word, that tells you all about how this USB interface works. So I tell you to basically install the embed driver, and then it'll just show up. Now, what I'm going to do is there's a couple different ways you can use this. At the lowest level, you can drive it all from like a command line. So I have a program called Putty. And let me drag Putty over here. And let me go serial. The baud rate is 115,200. And I just remember it was COM41 for me. So I have Putty, and I hit enter a couple times. And you notice I get a little prompt here with a little arrow key. So the first thing I'm going to do is you can always type help. And what it does is it gives you a command list of all the other things you can do. So commands are just a string with some other arguments. So let's go, for example, here's a quick, if we want to read from, and let me get a good example here. What are the general purpose analog input channels? If we just type in AIN, and then the channel, we'll say channel 0, notice it returns you a string that says AIN colon, the channel number, a colon, and then the voltage. Now, I have nothing hooked up, so it's 0 volts. So by doing this, you can kind of test everything. So if I say put in a T reads the thermocouple. So I'll go read thermocouple 0. Now I have a thermocouple on channel 0. Now it's kind of chilly in my office. It's 13¼ degrees C. And if I hit T with no argument, it returns all the channels. Now, if you don't have a thermocouple connected, it kind of gives the minimum value. It's a very small, negative 3,000 degrees. It's kind of goofy. But if you read through this document, I have all of the API kind of documented here. So you can take a look at that. Now, it creates an easy way for you to kind of talk to the box to verify things are working before you write your own program. And this functionality is enabled in that example program that I gave you. So let me minimize this, or let me just get rid of it. So what I did from here is to kind of show you how to do it in LabVIEW, is that I gave that document because it basically tells you all the commands you send. So each command you send a string with a character and a line feed, and it always just returns another string with data that you can parse. So I'm going to close Putty here. Yes, I want to close. And in the Dropbox, I have raw design files. I'm going to go under SRC for source, LabVIEW. And I have this example program called Chem Box Test app.vi. Now, it's not the prettiest it's not the prettiest VI in the world, but it will show you how you can kind of make your own LabVIEW program. So let me drag it over here. Here's my test app. What I'm going to do is I'm going to click COM41 and then press go. So what this program does is it basically automates all of those command line, strings to control the box. So, notice whenever I click on the solenoid channels, what it does, it shows me in this window, the commands that got sent out, to do the whatever switch. Now, all of this stuff, for example, the DAC, you can see all the output commands for the DAC. I can slide these up to control the DAC outputs. The MFC power controls on a relay. I'm sitting by a box so I can hear the relay going off and on. You can turn the fans. I can see the fans going off and on. And this is the string that you can see down here that gets sent out over that serial port. Now, the other command that's in there is I have something called stream inputs. And what this does is periodically sends out the commands to read all the inputs back. So if I do this, you notice here I send out the T command, AN command, 4 to 20. And what this does is keep sending out commands so I get analog data back. So you can see on the miscellaneous analog ADC inputs, these are just kind of floating around because nothing's connected. I can see my temperature sensor. Now I'm going to go over, you won't be able to see this, but I'm going to grab the thermocouple wire. There we go. I'm wiggling it, it wasn't quite in there. Yeah, it's 21, 20 degrees C. Let me touch the end here. Well, I think I'm interfering it with my hand here. Let me turn on a hot area. That won't electrically interfere with it. Oh, there we go. I can see the temperature going up. Yeah, that's quick. I've got a very hot air gun over here. We'll let that cool down, and you can see it cool down. And so there it is. It's just a LabVIEW program. And I'll just show you real quick how it's structured. I hit stop. And I'll go window, show block diagram. Now, all LabVIEW programs can be somewhat complex. But the way this program is structured is that I have a huge sequence structure that wraps all, around the whole program. So in the sequence structure, the first thing I do is that I initialize the COM port, and I set up some buffers, and then I just initialize all those controls on the front panel with these local variables. Now the next frame, all the next frame in the sequence is a bunch of parallel while loops that do different things. So let me kind of step you through it and it'll make sense. Now for serial port, sometimes in LabVIEW it's tough to write a program that you have like multiple things going in and out of serial port. And the best way I've kind of figured out how to do this is with what are called queue objects. So in LabVIEW, I have two queues, one called output command queue and input command queue. And all they are is I create a new queue that's a queue of strings. And I have two while loops, and the only thing they do is look at these queues, in this case they're at a kilohertz, every millisecond, to see if another function has put something in the queue and sends it out. So if we look at the output command queue, notice how I check the queue size, and if there's elements, I dequeue it and then write it to the serial port with this VISA serial write command. So with your LabVIEW, you're going to have the VISA serial drivers enabled. Now on the other side, I have a loop that always looks at how many bytes are at the serial port coming in, and this is for the data coming back, the data that the control box would send back to me. What this function does is, because everything in this USB interface works with carriage return terminated strings, that's what I'm kind of looking for. So what this does is it's a loop that builds up. It reads things from the serial port and continually looks for a carriage return. When it finds a carriage return, it takes the string it built up in a shift register and puts it in a input command queue. Then what I do is I just have another loop, scan the input command queue, and then decode what's in there. So each one of these sub-VIs is programmed to look for a specific string, for example, the temp string, the 4 to 20, and grab the data. Now what I do to command the unit is kind of the opposite, is I use this structure inside this while loop that scans for changes. In LabVIEW, I believe this is, right click here, programming, structures. This is an event structure that looks for changes in, for example, anytime I change the value on the solenoid channels. What I do is I write a little loop that builds up the necessary control strings, and then I dump it to an indicator on the front panel, and then I put it in the command queue. Then the other loop just dishes it out. So really all this program is doing is it has these input and output queues that I put strings into or read from, and then I kind of use what was in that Word document to kind of put together the different commands for the different functions. So this should get you started, that if you want to write your own program and make it fancy, I would just take this and kind of edit it, because it has everything you need to put maybe a nice graphs for temperature, and you can literally design your whole program to use the Chem control box is like a big DAC, that has, everything in it. Now, the advantage of the Chem control box is that we could put the whole control system in the mbed itself, so it's nice and stable, and you don't have to worry about a PC crashing. And just use the LabVIEW interface for the monitor. But this is an example. So what we're going to do now, let me close this up. Now, as a word of advice, is that if anything ever happens, like you unplug the USB interface while the program's running, is that sometimes for this to work, you've got to shut down not only your LabVIEW program, but everything. Like LabVIEW has this first window. You've got to close LabVIEW down completely before you can use that serial port, even in a different program. So there we go. So let's go back to the program. So what I'm going to do is I'm going to stop this video here. So this gave you kind of a start to play with. And in the next video, what we're going to do is go through the source code kind of line by line so you get an idea of how to use it. And once you see it, I think you'll get it. It's really not that hard, and it's just writing C code. And I'll show you the kind of start of a basic control algorithm. Perfect.